Everyone, welcome to topic 9.3. We're going to go ahead and talk about circles on the coordinate plane today. And just a little recall here, we have our formulas over here to the right side. We're talking about circumference and area. We're switching it up from perimeter to circumference, and we're going to keep talking about area. Now, for some of you, you guys have these formulas committed to memory. For others, they're a little bit more challenging, so please make sure that you are committing both of these to that memory. And for those of you who like those little mnemonic devices, a student told me in the past to remember the formulas. They said that cherry pies are delicious and apple pies are too. And that's kind of how they remember their formulas. But whatever works for you is fine with me. Okay, just a little food for thought here. This is kind of where the area of a circle formula came from. If you take a circle, you can break it up into, right here we have fourths, okay? And if we break it up into fourths, this edge here would be known as the radius because that would be the length from the center of the circle to the outside edge. Or we could break this thing up into however many pieces of pie that you want to, and we kind of get down to something that looks like this, where these are all now starting to be flattened out versions of the pieces that go all the way around the circle. And once these start flattening out, we understand that this is just the amount of radii times pi. So if we kind of look at it here, as we move down here even further, we eventually flatten this out to a rectangle. And we know that the area of a rectangle is just base times height, or radius times pi times radius, which then gives us pi r squared. But for those of you who like to commit that formula to memory, perfectly fine with me. All right, so let's practice a couple. We're going to keep this short and sweet today. Most of you guys, this will be a review, so let's go ahead and go for it. In this first example, we have a circle with a radius of 4. And we're going to find the circumference and the area of this circle. So remember, circumference is equal to 2 times pi times the radius, or pi times diameter. And for those of you who forget, remember, the diameter is just 2 times the radius. So our circumference here would be 2 times pi times 4. Our answer in terms of pi, that means we leave pi in our answer, would be 8 pi. But if we actually round to the nearest 10th, okay, we would do 8 times, and then a lot of you have that irrational pi button on your calculator, you would get 25.1. And that would be in units. But specifically, our answer said in terms of pi. So we will go ahead and leave this guy as our answer. For our area is equal to pi times the radius squared. So in this case, it would be pi times 4 squared. And remember, in terms of pi means we leave pi in our answer. So we do all the math and we leave the multiplication of pi written within our answer, or we don't evaluate with the pi button or the decimal 3.14, okay, the rounded version, sorry. So this would be 16 pi, and this would be square units. So this would be how we would leave our answer for that one. Number two says we're going to find the radius and the area of a circle. This time we're going to have to work backwards because we're going to be given the circumference. So we know that circumference is equal to pi times d, and in this case, we're going to set that equal to 314. We're going to go ahead and divide by pi to get our diameter by itself. So we would have the diameter equals 314 over pi. Now, they asked us, though, to find the radius. Well, we need to take this 314 divided by pi and then cut that in half, or we could say that the radius is equal to 314 over pi multiplied by 1/2. So our radius is actually equal to 314 over 2 pi. Notice, I'm not putting this in my calculator yet because we don't want to round in the middle of our problem. So right now, we're just going to go ahead and kind of leave this as is here, okay? If you were to put this into your calculator, you would get right around, if we rounded to the nearest 10th, right about 50, okay? But we're going to use this fraction in order to keep going and now find our area. So our area is going to be equal to pi times this radius squared. Okay, so if you go ahead and put that into your calculator, you should go ahead and round to the nearest tenth. You get 7,854.0. And then in this case, this would be square centimeters for our area. Okay, where our radius would just be units in centimeters. Okay, number 3, working backwards again, says find the diameter with an area of 20 pi. Well, we know area is equal to pi r squared, which is equal to 20 pi. So if I want to find the diameter, I need to solve for the radius and then multiply it by 2. So first I'm going to start by dividing by pi, or for those of you who were noticing, the pi's are going to cancel on both sides anyway. So we'll have a radius squared equals 20. So then in order to get this radius isolated, we need to go ahead and take the square root. So our radius is going to be the square root of 20. Okay, but remember, I don't want to round in the middle of my problem. So I'm going to go ahead for our final answer of our diameter, I'm going to do 2 times the radius. So 2 times the square root of 20. This would be your exact answer, 2 times the square root of 20. And then if you put that into your calculator, 2 times the square root of 20 gives you 8.9. So both of these answers would be acceptable. And then in this case, we would just put units because we don't know what the specific units are. Make sure you have this in your notes, and let's continue forward. For this one, it says find the circumference and area of a circle with the center of our circle at -1, 2, and the point -5, 5 is on the circumference. So now we're going to go ahead and put these shapes onto a graph now that we've reviewed a little bit. So right here, this point -1, -2, this is going to be our center. So if this is the center of our circle, that means that the length from here to here would be our radius. And then if you can kind of imagine a circle, this is going to look like more like an egg, but that's okay. Kind of goes all the way around our radius, like so. Just go with it. All right, so then it says we're going to actually find the circumference and the area. Well, in order to find circumference and area, we need a radius, or at least a diameter. So let's go ahead. We need to actually find the length of this radius. So if you recall from last time, we found the length of a segment on a plane by using the Pythagorean theorem. So I went ahead and drew this right triangle here. So this is going to be a 4 by 7 right triangle. So 7 squared plus 4 squared equals our radius squared. And if we go ahead, 49 plus 16 equals the radius squared. So r is going to equal the square root of the 49 plus the 16. Now when we go ahead and put that in, we get the square root of 65. But remember, don't round before you finish your problem. So our circumference, we're going to go ahead and just use the radius as a radical. So for our circumference, it would be 2 times pi times the square root of 65, which is our radius. Now we can go ahead and round. So if we did 2 times pi times the square root of 65, we should get 50.7. And this would just be written as units. Now for our area, we're going to do pi times the square root of 65 squared, because it'd be pi times radius squared. Well, when we square a radical, remember this just becomes pi times 65. And then if we needed to leave our answer in terms of pi, we would leave it as 65 pi square units. If we were rounding to the nearest tenth, you would simply do 65 times that pi button, or 3.14, depending on whatever your instructions tell you to do. And this would be 204.2. I apologize for the background noise. moving forward, let's go ahead and let's have you guys attempt one of these problems. So let's go for it. Go ahead and give this one a try. So now we have a circle with its center at -3, 4 and a point on its circumference. Go ahead and actually calculate the area and calculate the circumference. So first find the value of the radius and then go ahead and calculate the area and the circumference. Pause your video and work. Go ahead and check your answer and be sure that you have this correct. So you first start with your Pythagorean theorem to get your radius. Go ahead and substitute that value as a radical into your formulas and then round at the end. So you should have gotten 51.8 for the radius and then 213.6 for your area. Last type of example with this, then we're going to talk about the equation of a circle. So this time we have point A, which is at 9, 4, and point B at -3, -1. This is actually representing our diameter. So this time a little bit larger, and we're going to actually call this circle C. Circle C means that C is the center point. So we're going to go ahead and draw the circle in the coordinate plane. Now, for those of you who have greater artistic skills, you can go ahead and see that this should be like a semicircle, and then it should continue over here. Now, mine looks kind of like an egg. All right, so if we attempted that as a full circle, we could go ahead and maybe I'll apologize here. We're going to go ahead and stick with the dotted line version of this for the sake of sanity. Once you commit to drawing, you just keep on going. All right, so that'll be our circle that we sketched here. So we're going to go ahead and find all of these parts here. So A, B, C, D, and E. For point C, we know has to be located in the center of this diameter. So if you call back to the deep dark days of August or the beginning of the school year, we used a formula called the midpoint formula. The center point of that circle is also going to be the center point of the diameter. So for part A, I'm going to go ahead and use our midpoint formula, which was x1 plus x2 all over 2, and then y1 plus y2 all over 2. Essentially, we're finding the average of our coordinates. So in this case, we're going to go ahead and call it point C, because it is circle C, and we're going to go ahead and substitute our values. So this would be 9 plus a -3 over 2, our x's, and then we would do 4 plus a -1 over 2. So then point C, 9 minus 3 becomes 6 over 2. 4 minus 1 becomes 3 over 2. So we would say point C is actually located at 3, 1.5. Now that we've identified that as our center point, we could go ahead and graph that to be about right here, and we would go ahead and call that point C. So now we know this is our radius, this is our radius, this whole blue line is our diameter. All right, so let's go ahead and find part B. Part B says we're going to do the length of our diameter. Well, the length of diameter simply means we need to make a right triangle and go ahead and use Pythagorean theorem. Okay, because all we did was find a coordinate for our center point. We didn't actually find any length yet. So our right triangle here is a 1, 2, 3, 4, 5 by, if we're going all the way over, this would be 12. So for our diameter, we would do 5 squared plus 12 squared equals diameter squared. Or in this case, the diameter equals the square root of 5 squared plus 12 squared, or the diameter equals the square root of 169, which is 13 units. Once we have that, moving on to part C becomes pretty clear to us now, because we know that the radius is simply the diameter divided by 2. So 13 divided by 2, our radius is 6.5 units. Finally, for parts D and E, we're going to use these values to actually solve for the circumference and area. So part D says circumference. So we can do pi times diameter, which would be 13 pi. Or if we substituted that in, remember rounding at the end, 13 times pi gives us 40.8 units. Or you could leave it as 13 pi. Okay, it did not say round to the nearest tenth or anything. And then finally for part E, area is equal to pi times our radius, 6.5 squared, so our radius squared. So we get here 42.25 pi. And if you put that in your calculator, you get 132.7, and this would be square units. Both of these answers would be acceptable. Once you have this process down, go ahead and try one on your own. Go ahead and pause your video, follow the same steps here. Now we have M and R representing the endpoints of our diameter. Go ahead and find the midpoint and then length of your radius and your diameter, and then go ahead and substitute those values. Checking your work, you should see here that our center point T is located at negative 2.53. Obviously we have a 17 unit long diameter, which means that the radius is half at 8.5, and then substituting those values, you get a 53.4 unit circumference, and then you get a 227 unit, a square unit area of that circle. So make sure you check your work there, and you probably have a much better sketch of a circle on your graph. Finally, we're going to talk about the equation of a circle. We will dive more into this when we get actually into our circle unit, but for right now, I'm just going to show you the bare bones of this. So this handy dandy thing here, this is called standard form of the equation of a circle. If you're paying attention, it kind of looks like the Pythagorean theorem and the quadratic formula kind of blended together, more so the Pythagorean theorem, because right here, we've got like an a squared value plus a b squared value equals a c squared value. And it actually works like this, where if we draw a right triangle around our radius, we can go ahead, I'm sorry, not around the radius, but if you draw a right triangle so that the radius is the hypotenuse, you can actually use coordinate geometry to manipulate this equation. But the important thing for us, for the sake of this section, is that in this equation, notice we have negative signs, which are going to be important because we're going to refer to those as opposite. So opposite of h, opposite of k. And our point hk is the center of the circle. So h and k simply represent an x and y value, and they just represent literally the center point of whatever circle you're working with on the graph. The length r is still the radius, but notice in the formula, it's referred to as r squared. So that's going to be a squared value of our radius. So let's practice identifying some key parts of this equation. If you have yourself this equation here, right here we have the opposite of 1, where 1 is going to be our h value. We have the opposite of k, where k is going to be our 6 value. And remember, this 9 actually represents r squared in our formula. So for our center point, remember our center point is h comma k, but that negative sign or that opposite sign is part of the formula. So we're going to pull the opposite value out. So our center point is not a negative 1, but it's actually the opposite of negative 1, which is 1. And then our k value is the opposite of negative 6. So if I was to plot this on a graph, over 1, up 6, and we would put our point somewhere here. That would represent the center of our circle. Now our radius, now our r squared value is actually equal to 9. So our actual radius is the square root of 9, which is 3. So I would go ahead and go 3 units out from the point, 3 units up from the point, 3 units down from the point, and 3 units over from the point. And I could use all of that to then make a circle with a radius of 3. So obviously your sketch might look a little bit more detailed and savvy, it's really hard to draw with the stylus here. But moving forward, next and final example here, notice this time we have x squared all alone, but x squared is the same as x minus 0 squared. So as we pull out our h and k values, our h value is simply 0. Our k value is the opposite of positive 4. So remember, you always pull the opposite out. So our center here would be at 0, negative 4. So our center here for this circle would be right here on our graph. Our radius this time, remember r squared equals 10. So our radius is actually the square root of 10, which is roughly 3 point something. So, but in this case, we're not necessarily going to use that rounded value. We're just going to go ahead and understand that this is about 3.2. So if we were to sketch our circle, we'd probably go about 3.2 units out, 3.2 units down, 3.2 units up, and then 3.2 units over, and then we could sketch a circle like so. Okay, we know that the radius here would be the square root of 10. All right, finally, we have gotten to the homework section. This time, you guys actually have a worksheet. It is attached to the assignment in Teams, and it's also attached on Portal. You are graphing emojis. Woo, 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 woo. When you're following the instructions, you're going to graph a bunch of different points. They'll make several different emoji pictures, and then as you complete this whole assignment, part of it is asking you to identify 2 of the circles, any 2 you want, on the graph, and you're going to find these following things within that circle. So find the center point, pick 2 points that you know represent the center and the the radius, or a point that would be on the circumference, and then go ahead and show all your work. Make sure you're rounding your final values to the nearest tenth in order to find area and circumference, diameter, and radius. Go ahead and color that thing, color your emojis, make them nice and pretty, and go ahead and scan your image then of your work and your emojis and turn them into the assignment. Thank you for listening and have a productive day.